Thanks very much for the invitation and for the initiative of organizing this. This is a good time to take stock and reflect on next steps needed. So what I'm going to do, Noah and I were actually on a panel not that long ago for the California Climate Change Conference, and so I think it was reversed order. But I'm going to tee it up, but I have an idea of what he's going to talk about, and he has an idea of what I'm going to talk about. So I will give some insights about the new normal, not as a climate scientist, but as an economist who's been working with some other folks, including Jay Lund and some other colleagues from UC Davis, as well as from Point Blue Conservation Science and PPIC, on what we're seeing in this drought and the impacts on different sectors and how we should be thinking about the new normal from that operational perspective. So just a different slide to show you that droughts are something that are a kind of recurring feature of our climate. The orange bars below the line, those are years with below average precipitation, and the blue ones above the line are above average. It gives you a hint that there are also floods that we have to sometimes prepare for. And you can see that this is not the longest drought that we've experienced since we began keeping records of this. There have been several that have been longer, but it has been especially tough, and that a lot of that has to do with the fact that it's been very hot. So this is a graph showing you average temperatures statewide. The bar is the average over the full period. This is since the early 30s, because that's when there have been more places where we've been recording temperatures, so it's a better way of kind of seeing averages. And you can just see that spike there that is, highlights just how hot it's been. It's just been much warmer both in the winter and in the summer. And I know we'll be able to talk more about kind of the part of that's the climate signal, and the part of that's related to some an unlucky monstrous blob in the western Pacific Ocean that I don't know, that maybe Godzilla El Nino is going to come and do battle with now. But what we do know is that the climate models are predicting that it's going to be getting hotter. So even if it cools down a bit when the ocean conditions change, the upward trend is something that we should be expecting and that we have to prepare for. So in that sense, it's given us a bit of a foreshadowing in this drought of what we have to think about. Now, we looked in a study that came out in August at water availability for California if it stays hot and dry for the next 2-3 years. So if we don't get a big bailout with the El Nino this winter, and what that meant for different sectors. And just to give you a highlight of the story we're looking at, is very similar in some ways to what we've been experiencing over the last couple of years, with a big reduction in runoff, 25 to 40% of average, big reduction in storage. The runoff part is important really to think about from an ecosystem perspective, as well as for what cities and farms are getting. Big surface water cuts for farms. As Jay mentioned to you, there's been big increases in pumping in order to not completely make farmers whole, but to help compensate for that loss in surface water. Cities have had various ways that they've been coping with that too. We've had a lot of curtailments of water rights that would likely be expected to continue and intensify if it stays dry. And we've seen already about a 50% cut in hydropower availability with this drought relative to recent averages, which has increased electricity costs by about 2%. So the other big thing to remember is just water quality also suffers during droughts, and water quality in this case, it's partly salinity. So managing salinity in the delta is much harder when you don't have as much fresh water coming into the system from upstream, but also temperature, which is actually a very important quality parameter for us in how we manage ecosystems, because we have to, Jay showed you the map of all of those, the former salmon habitat that was cut off by dams, all those red squiggly lines. Well, what that means is that we now have a system for managing where we release cold water from dams to lower level elevations in order to keep the water cool enough for spawning, and that's just much tougher when it's both dry and hot. So just run through quickly for you the 4 areas of concern and how we need to think about going forward, future droughts, and how to prepare for them, including also if it stays dry. So cities and suburbs are the best news so far, and this is really a reflection of the fact that there's been a lot of learning in our urban environment about how to prepare for droughts. And this is in this largely decentralized system that we have, But where the state has been, I liked what the professor from Israel was saying about carrots. The state actually has provided a lot of carrots for this in terms of incentives, matching funds from state bonds, as well as combined with regulations saying if you don't do a drought plan, this was back in the early 90s, you're not eligible for drought funding. And sort of regulations like that basically call on local agencies to do the kinds of things that they need to do to get more resilient, but then also providing incentives in terms of matching funds. So there's been a lot of funding available to support local projects like interconnections, local storage, local groundwater storage, and so on. We've seen a lot of regional cooperation happening, in part with incentive funding from the state, and conservation has been helping urban and suburban agencies. Now, with continued drought or future droughts, we're going to see supplies being more constrained as drought conditions get tighter. We do have something to tackle, and there was actually a Senate hearing on this yesterday on the water funding side, which is that right now we've kind of boxed our local water agencies into a small space in terms of the flexibility they have on pricing and on raising fees by in some ways requiring too precise of a kind of cost accounting, so that every drop has to match every penny. That was one of the people testifying yesterday used that analogy, and what it means is that things like recycled water, using it as a water supply, or capturing stormwater and using it as a water supply, it can be harder to price those kinds of things and not have somebody take you to court. There are also some challenges with the conservation mandate, just in making sure that it's flexible enough not to be harming some businesses and industries that need to need water and are already being efficient. But overall, the urban and suburban economy is in pretty good shape and is pretty well positioned to handle drought, and just basically has to be continuing on the path that they're on in order to become more resilient. Jay mentioned to you some of the details about agriculture, and he was referring to results of some work that UC Davis did for the Department of Food and Agriculture, both last year and this year. And so this just highlights some of those takeaways in terms of thinking about the future. Groundwater pumping is a smart short-term thing to do. Groundwater is going to be a smart long-term thing to do, but we've got to do a better job of managing our groundwater basins for that. We've also got to be thinking about improving water trading, because trading is really a key thing for farmers who don't have access to groundwater and who don't have senior water rights, to be able to keep the agriculture going that's generating a lot of revenues and jobs. The expectation based on the work done for CDFA by Jay and colleagues is that with continued drought, we're not looking at a falling off a cliff situation. We're looking much more at a sort of creeping, increasingly tough problem, but where there's still a fair amount of adaptive capacity in the agricultural sector to be managing in this way. So really thinking about how to address some of the challenges and some of the external impacts of groundwater pumping, like subsidence, and that's a localized thing where you really have to worry about the infrastructure damage, dry wells in some rural communities. And that's where I'll turn to now briefly. This is something that has really started to be in the spotlight in this drought, which is not large populations, but very vulnerable populations in small towns, folks that are on small water systems, individual domestic wells. The state has been tracking this and really working to try to address the problems, but it's turning out to be tough, and we're partway there, I would say, in terms of really providing an effective response to folks who are low income to begin with and who are running short of water because their well systems are shallow and they're going dry. So this map just kind of highlights for you the reported domestic wells that are dry. This was back in late spring. The numbers are higher now. So continued drought, we're going to have to be prepared and expect more of that happening, as well as worsening air quality. And just these are also often the folks that are going to be hard hit if there is land fallowing, increased land fallowing, because a lot of them are the folks who are going to lose jobs. Ecosystems, and I'm going from like the best to the worst here. So this is the worst in terms of real crisis. In contrast to cities and farms that have been able to pump some extra groundwater, during this drought to make up for the shortages of surface flows. That's really not a viable strategy in general for the ecosystem. We looked at what's happening in river systems, especially with fish, what's happening in wetlands, which is especially important for water birds of the Pacific Flyway, and then what's happening in California's forests. And there's just been tremendous reductions in flows and in habitat, increased wildfire risk. This has been all over the news, so you've seen that. The good things that have been happening so far in the drought are increased agency cooperation, which has really helped to make do with the limited water that is available, and also intensive cooperation in forest management and wildfire management as well. Rescues and monitoring, a lot of real extraordinary kinds of steps made to try to get fish into places where there's still water, and some innovations in waterbird management that are especially interesting. I don't know if the term pop-up wetlands has. Have you heard of that yet? But that the idea there, and this has been something that the Nature Conservancy has piloted in places where farms usually provide some wetland habitat, like the rice fields in the fall and winter, as part of the normal process of decomposing the rice straw. Well, when you don't have as much water, there's not as much rice grown, and so on. So they've been paying farmers, knowing where the birds are, in sort of strategic times where they're going to be, paying farmers to temporarily water their fields to create habitat. So it's a great kind of incentive system to increase habitat. With continued drought, and I would say, looking ahead to future droughts, these are the kind of things we have to really think about. So with continued hot, dry drought, we're looking at the risk of a lot of fish species extinctions. In the near term, we identified 18 fish that are at risk of extinction in the next 2 to 3 years with continued hot, dry conditions. And so we provide some recommendations for some emergency actions that include things like conservation hatcheries, where you're basically protecting the biodiversity in a hatchery so that you can release the fish back into nature once conditions improve. There's also really room for allocating strategic flows in these cases, and that can be done through regulation, but it can also be done, again, through the pop-up wetland kind of model with some incentives to farmers. Very big risks of high waterbird mortality. We have about 5 million waterbirds that fly through California in the Pacific Flyway, and with the shrinking wetlands, we have to really be on it in terms of managing that very carefully and putting resources into that. Severe wildfire risk. Since we came out with this study, 3 new fires have made the top 20 of all-time list, just to give you a sense of how tough that is. More funding can help with this. This is an area there has been some funding devoted to the ecosystem during this drought, but it's pretty small. And this is an area where we're definitely a lot of bang for the buck in terms of adding some dollars here to help in these various ways. So just to wrap up, what we need to do and what we need to think about with the new normal in California, build on what's working, and what's working is these diversified water portfolios with, and I think what the professor from Israel was saying about recycled water, that's definitely on the radar. We already do it some, but it's on the radar to do more of that, as well as more interconnections, more regional infrastructure development so that there can be regional sharing. Coordinated emergency response among state, local, federal agencies is something that's working but has to get even better in terms of planning. Works in progress, the mandatory conservation idea. That's something, it's important for the state to send a signal, but also to do that in a way that's flexible and that also still provides incentives to locals to invest in water supply. And Jay and I were just talking beforehand, and he was suggesting an idea. For example, one incentive that you might want to provide is if an agency is increasing their recycled water, capturing the recycled water, that could be a kind of credit toward overall water savings as a way of incentivizing that kind of investment. Water pricing, I mentioned to you some of the challenges there. That's probably an area where it's going to be worth looking to California voters for some constitutional cleanup legislation. Rural community supplies, planning for making sure that beyond this drought that there's resilience there, and that's often going to involve connecting them to larger systems. Groundwater management, we've just launched a big agenda in California with the new groundwater law and sustainable management. And some of the things about water trading and waterbird management that I mentioned to you, there's room for improvement, and this is the real tough list. here of difficult work ahead, or sort of what's not working yet. So improving how we manage curtailments, and we've been doing some thinking about this and have a report coming out soon that will talk about some suggestions there. Modernizing water information, that's what Jay highlighted in terms of water accounting. Again, some improvements there. The legislature passed a law that just this summer that is going to improve reporting requirements and measurement, and we can do more. Managing forests. Time has come to really put in action some of the upper watershed management plans. Everybody knows what we need to do. We just need to get the resources to do it. And that involves cooperation with our federal partners on that. I think there's a lot of interest by other states as well. And I'll just conclude by saying that rebuilding environmental resilience is going to be really key, and that involves not just the sort of emergency management, but having an action plan to improve drought resilience in the ecosystem, so that we're not just having to truck fish around. And I will leave you with a beautiful photo of clouds that we hope will be coming our way soon. Thank you.
Thank you, Dr. Hannick. Dr. Tivenbaugh.
I can use that. Yeah, sure. Okay. Oh, well, thanks a lot for having me here. It's a real pleasure. And I guess I'll start with the punchline. So this question: is this a new normal? Is this global warming? The short answer is that yes, we have a number of different lines of evidence from a number of different research groups that global warming has intensified this drought, and that it's increased the probability of the conditions that are creating the drought. And in terms of the new normal, I think it's clear that we're in a new climate in which warm or severely warm years are the normal, and therefore when we do get low precipitation, they're very likely to also occur with warm conditions. That doesn't mean that this drought will last forever. That doesn't mean that California's climate will be a perpetual state of drought, or that California will turn into a desert. But in terms of low precipitation coinciding with very warm conditions, that is the new normal. So this is the global temperature time series, just to remind ourselves that global warming is happening. It's an observation, and we've now hit the 1 degree C level above the pre-industrial, and we have the Paris negotiations coming up later this month and into next month, and various targets are being discussed. But we're about now, very recently crossed that 1 degree threshold, which is halfway to the 2 degree threshold. And really, the message that I want to convey in terms of global warming and drought and the climate of California is really of risk. And what we experience in terms of extreme events is a product of the physical climate conditions, whether it's precipitation, temperature, other climate conditions, and also how those conditions interact with the exposure and vulnerability of people and infrastructure and ecosystems. And what we're seeing in California is, in terms of the climate, is an increase in the probability of the hazards in terms of the co-occurrence of low precipitation with high temperature. But we're also obviously seeing changes in exposure and vulnerability, and we have opportunities to manage our drought risk in all three of these different dimensions. All right, so the current drought, the ongoing drought, is now clearly the most severe in our historical experience by many measures. And it's been an interesting event as it's unfolded. Certainly, the extremely low precipitation was kind of got the drought kicked off. But we've also seen more recently in the drought the role of the record warm temperatures in intensifying and prolonging the drought. In fact, the last the last quote wet season, the October to May period that we had most recently, actually was not even among the 5 driest in California's recorded history, and yet we're still in the most severe drought conditions that we faced, and that really highlights the role of temperature in drawing water out of the soils, stressing plants, melting snow. First, sort of the anatomy of the precipitation, because clearly we wouldn't be in this drought without the low precipitation. So this really starts with the atmospheric conditions in terms of the proximal cause. What we've experienced during this drought is this, for various times, not throughout the whole period of the drought, but during the periods where we've had very low precipitation, is this ridge of anomalously high atmospheric pressure, termed the Ridiculously Resilient Ridge by Daniel Swain, who's a graduate student in my research group at Stanford. And you can think of this essentially, we get our storms in California across the Pacific, and you can think of this ridge of high pressure acting somewhat like a boulder that's dropped into a stream. The water's going to move around that boulder, and that's exactly what we've seen during the dry periods. In terms of the low precipitation periods during this drought, is the blocking of storms by this high pressure system. And here's an animation for part of the drought period that Daniel put together. So you can see it's not actually a boulder. It's not a boulder in the sky. It is a dynamic feature, but it's been more consistently present during this drought than at any other previous time in our atmospheric observations. What this has produced is, in addition to record high temperatures, also record low precipitation. And one example is up on the screen here. Each of these gray traces, as we refer to them, is a year of cumulative precipitation, and you can see calendar year 2013 in red, which was the lowest calendar year precipitation on record by a large margin. Our published work on this atmospheric feature suggests that it's considerably more probable in the current climate than in a climate without human forcing. We have some follow-up work that's currently going through the review process. Daniel will be presenting it at the upcoming American Geophysical Research Union meeting in December, but we think that we now have even stronger evidence for this conclusion than we did before. So I want to turn next to temperature, because as I mentioned, temperature has been a very prominent factor in this drought, and I'll show some results from this paper that came out this spring. And I want to start with the San Francisco Chronicle version of the data. It's a little bit easier to look at than what we published in the paper, but these are the same data as we had in the paper, just more graphically accessible. And what you see here on the left is the precipitation time series, similar to what Dr. Hannock already showed. In the middle is the temperature time series, and then on the right is the National Oceanic and Atmospheric Administration drought indicator for California. And what you see is there has not been any trend in the annual average precipitation in California. There is considerable variability, as we already heard in the previous presentations, both wet and dry years. But what we have seen in California is very clear long-term trend towards warmer conditions in California. And the result of that long-term trend in temperature, that long-term warming, is an increase in the probability that low precipitation years are also warm. And if we look back at the historical record, about 120 years of observations from California, we see that over the course of that record, about a quarter of the years have had low precipitation and warm temperatures, and about a quarter have had low precipitation and cool temperatures. And those low precipitation years that were also warm have more than twice the probability of producing severe drought compared to low precipitation with cool temperatures. And if we look at these same data, but in what some people call a shotgun plot, so you have the precipitation anomalies along the horizontal axis, so wet years going to the right and dry years going to the left, and then you have the temperature anomalies along the vertical, warm years up and cool years down. Throughout the course of California's history, this has essentially been like flipping two coins, and the precipitation coin has come up tails half the time and heads half the time, and the temperature coin has come up tails half the time and heads half the time. And it really has been, at least for the first century of observations from California, really quite independent, and about a quarter of the time they both came up tails, and that gives a double the risk of severe drought. If we just pull out the last 20 years, we have a really different climate. We have a climate in which 80% of the years have been warm years. And so California is really moving into a regime where it's somewhat akin to Lake Wobegon. I don't know if you listen to Prairie Home Companion, but it is a place where all the kids are above average. And California is moving into a regime where all the years are also above average in terms of temperature. So what this means is that we're getting, even with getting half heads and half tails on the precipitation coin, we're getting a lot of tails on the temperature coin. And what that means is you have a much greater chance of getting two tails, and that's exactly what we see in the historical record. So if we compare the last 20 years to the previous century, there's been a doubling of the frequency of drought in California. There's been a doubling of the co-occurrence of low precipitation with warm conditions. And there's been a doubling of the efficiency, the percentage of low precipitation years that do end up producing drought. That doesn't mean that it's global warming that's causing that. So we use climate models to ask that question. The reason we use climate models is that we can't put the global climate system in a lab and run thousands of experiments on it like we can with Petri dishes. So instead we use these physical climate models to run the kinds of experiments we'd want to run in the lab. And what we see, just to summarize the results of the climate model experiments, is that the long-term warming of California and the associated increase in probability that low precipitation years are also warm, those are both very unlikely to occur in a climate without human activities and are likely to occur in a climate with human activities. So we have very high statistical confidence that both of those, the long-term warming and the associated increased risk of low precipitation occurring with high temperature, are caused by the human emission of greenhouse gases to the atmosphere. If we look out into the future and ask where are we headed, as I mentioned, we're already in the observed record on the cusp of 100% risk of warm years. And if we look out in the future, again, using a large suite of climate model experiments, we see that right around that 2-degree level of global warming, California is likely to hit a regime in which all of the years are severely warm. And what this means is that while there are still wet years and dry years in terms of precipitation, when the dry years do occur, there's essentially 100% risk at that 2-degree level of global warming that the low precipitation is happening in an environment that's severely warm, which is just what we've experienced during this drought. The last comment that I want to make is about snow, because this is very important for California's water resources, as we've already heard, and it's an area where there's a hard threshold that's a very a physical threshold, and so there's not water freezes below the freezing point of water and it melts above the freezing point of water, and what we see throughout the western U.S. is as global warming unfolds, an increased risk of severely low snow years. And if we look in greater detail using finer scale data and finer scale climate models over the western U.S. What we see going out over the next 30 years, along with that increased probability of severely warm years, is an increased probability of low spring snowpack, more rain at the expense of snowfall, earlier melting of the snow that does fall, and that effect being more acute at lower elevations, but also being prominent at high elevations by the time we hit that 2-degree level of global warming. And so the last figure I want to close with is a figure from back in 1988. And this is a pretty potent reminder for me that these are the basic response of California's climate to global warming has been well understood for some time. And this, in fact, is another one of our speakers today, Dr. Glick's prediction back from 1988 of what is likely to happen to California's snow dependent water resources with global warming. You'll notice that this prediction compares today, which was 1988, to the year 2050, and in fact it's what we've already seen from 1988 up to the present, is a shift towards more liquid precipitation, earlier melting of snow, less snow melt available during the warm dry season. So we're seeing this unfold already in the current climate. So thank you.
Thank you.